Today we are going to solve equations that involve exponents, and so we're going to use what we know about third roots, fourth roots, fifth roots, whatever, to get rid of the exponent of 3 or 4 or whatever. So keep in mind, if you have something like x to the n, to undo x to the n, you would take the nth root. The nth root cancels out an exponent of n. So if you have x squared, you would have to use a square root to cancel it out. If you have x to the third, you would want to use a third root to cancel it out, and so on and so on and so on. But you can't take the nth root of something until that thing is isolated. You have to get that thing by itself using what we know about algebra before you take the radical. So step number 1, isolate the power. Keep in mind, like in number 18, 5y to the fourth is not 5y to the fourth. It's 5 times y to the fourth. So you have to get the y to the fourth by itself before you use a radical. How might we get rid of that 5? Computer's freaking out on me. Divide both sides by 5. That will give us y to the fourth equals 16. Because your perfects chart is so handy-dandy, always try to use your perfects chart first. If you can't find the answer on your perfects chart, then go to your calculator. So y to the fourth is 16. We need to take the fourth root of both sides. If you look at your chart, the fourth root of 16 is 2, and that comes from one of those plus minus columns. So plus or minus 2. Y equals positive or negative 2. If it's an even index, you have to put the plus minus in there, especially when you're solving equations. Number 19. What do you think we are going to do? Subtract 5. That gives us x to the third equals 27. To get rid of the cube, we take the cube root. With the cube root, we don't care about the plus minus, so look at your perfects chart in the thirds column for 27. When you find 27 in the thirds column, slide all the way over to the left, and you see that the third root of 27 is 3. Number 20, we have x minus 7 to the fourth equals 10,000. This time we have parentheses. The parentheses are raised to the fourth. You cannot do anything inside those parentheses until that exponent is gone. So we are going to take the fourth root of both sides. So x minus 7 equals, what is the fourth root of 10,000? 10. And because it comes from an even root column, it is plus or minus 10. Now we need to add 7 on both sides, and we're going to put that 7 in front of the plus or minus. So x equals 7 plus or minus 10. Technically, if you left your answer like that, it would not be wrong, but because 7 and 10 are both just plain numbers, we can combine our like terms and find out that our answers are 17 and, so using the plus, 7 plus 10 is 17. Using the minus, 7 minus 10 is negative 3. I'd like you to try number 21 on your own, and then we actually are going to add another problem over here. So some of my students are stuck, which is kind of awesome. We have y minus 1 to the third equals 32. The parentheses are completely isolated, so we need to take the third root of both sides. So we grab our perfects chart, we look in the thirds column, and 32 is not there. What do we do if it's not in the perfects chart? If it's not on your perfect chart, we're going to use our calculator. And I don't have an emulator on my computer for the scientific calculator. On the scientific calculators, you would do enter a 3, and then you use your second button, and then your exponent button, your caret. Right above that, it should say xth root. And then punch in 32 and hit equals. On this calculator, similar type of process. We have to enter the 3. Then we go to our math button. And the 5th option down is the xth root. And if your calculator is new enough and has the whole fancy math print, it'll take that 3 that you entered previously and stick it up into the exponent. If you happen to not enter the index first, if you just go to your math button and select the xth root, do you see what it stuck in the index? Answer. It stuck in whatever you entered previously. It wants to take what was previously entered and stick it into the index. If this ever happens, you can go up in here and delete out that answer and then enter the index that you want. So we want the 3rd root of 32. It is approximately 3.17. So y minus 1 equals approximately, what did I just say it was? 3.17. Then we would add 1 to both sides. That would give us 4.17. And some people would say wait until the end. So do y equals 1 plus the cube root of 32, and then enter it into your calculator and round. But as long as you're not rounding too harshly, don't round that to 3. It's definitely not 3. Make sure you have some decimals on there. Okay, I made up an additional example. I think you should have room for it somewhere on your paper. 2 times the quantity y plus 3 raised to the 4th plus 5 equals 29. The reason I gave you this example is I want you to see what you can't do. You cannot distribute. I even want you to write that in your notes. Do not distribute. I think PEMDAS is a little confusing sometimes because parentheses come first. So you think, oh, let's deal with the parentheses. Let's distribute. Distributing is not dealing with the parentheses. Distributing is multiplying. Parentheses means do the stuff inside the parentheses first. Well, we can't do y plus 3. Next would be exponents. You have to deal with exponents before you deal with multiplication. So we cannot do anything to the inside of this set of parentheses until that exponent is gone. And we can't get rid of the exponent until that thing is isolated. So step 1, isolate the thing that is raised to an exponent. That's what we need to isolate. So what should we do first? Subtract 5 first. Actually, when you're solving equations, I don't know if you guys have ever thought of this, when you're doing math, you use PEMDAS to tell you what order to do things. When you're solving equations, you're actually doing PEMDAS backwards. You're trying to undo the math that was done. So you always want to deal with addition and subtraction first, then multiplication and division, then your exponent, then your parentheses. And this problem is going to show us that entire process. We're dealing with the subtraction first. Is that 24? Then we're dealing with the multiplication. How do we get rid of that times 2? Divide by 2. We can't distribute it. We can't multiply it, so we have to get rid of it by dividing it. So that gives us y plus 4 to the 4th equals 12. Oh, you're right. Now we can get rid of that exponent of 4 by taking the 4th root. And it's not on the perfect chart, so we have to do the calculator. So calculator, the 4th root of 12 So y plus 3 is approximately, and I should use little approximately symbols, but that's okay, 1.86. Your calculator will not tell you the plus minus, but we know that that's an even index, so we need to put a plus minus in front of it. So our answer is going to be -3 plus or minus 1.86. And you can actually do that math. So -3 plus 1.86. One of our answers is approximately -1.14. And then do -3 minus 1.86. Approximately -4.86.